Oh class, before we go to division, does anybody want to share their feelings about multiplication? So now we talk about the rules of exponents and we begin with a multiplication and a division of the same base. Case number 1. Check this out. I have 2 to the 4th times 2 to the 3rd power. What shall I do? Before we think of a shortcut, let's do the long way first and discover it. So 2 to the 4th is expanded as this. 2 to the 3rd is expanded as 2 times 2 times 2. Since the operation in the middle is a times, I put a multiplication sign. Okay, guess what? All the bases are the same. Can you simplify it? Remember, mathematicians are lazy. They don't want this long one. They would make a shortcut. Same base, simplify as a single exponent. Yes, it's possible. So therefore, I write 2 to the, how many 2's do I have? 1, 2, 3, 4, 5, 6, 7. So I wrote 7. Easy. Okay. So what have you observed? What happened to the bases? You copy the same base. It's the same. No change. All right. What happened to the exponents? Did we multiply 4 times 3? No. What did we do? We added them. Because there are more 2's now. So 4 plus 3 is a 7. You got it. Now, one more. So therefore, if we know that, do I need to skip the expanded form? Yes. You can easily identify the final answer here. Again, but before that, let's just prove it. Okay, 8 written how many times? 7 times. 8 written down as a factor how many times? 9 times. And then you multiply them. That's too much work, Ram. Okay, so simply copy the 8. And what exponent will we have? Count all of this individually. Or you could, what will I do with this 2? Yes, add it up and you get 16. Again, copy the same base and simply add the exponent. That is what you call rule number 1 in multiplying. For any exponents with the same base, how do you simplify the multiplication? Check this out. Simply copy the same base, the b, and add those 2 little numbers, the exponents on top. Okay, so copy the same base, add the exponents. This is the first rule of exponents. Remember that. Now let's have some practice. Try this. Okay, pause. Okay, ready for the answers? Add these 2, you get 8, correct? Add these 2, you get 18. Add 11, 6, and 10. There you go. Whoa, some of you got this wrong. Why? Because you can only add the 35 base. So 35 to the 14th power, but 36 has a different base. Probably you didn't see that. Okay, so I cannot combine different bases, so I just leave them as it is. Bases cannot be combined. Leave it as it is. All right, next. 15 to the 12th power. Why did it become 12, Ram? Where did you get the other one? Take note. If there's no exponent there, there's a hidden 1. I repeat, if there's no exponent to a base, there's a hidden 1. So you have to add that 1 to the rest. Okay, next, try to think. Ready? And go. Whoa! Why didn't you combine that, Ram? The bases are the same. Look at the sign. It says plus. Plus. So the rule only works for multiplication and not for addition. So, do not include the plus 79 to the 5th power. Only this one with the same base can be simplified. Alright, case number 2. Remember, the first one is the rule about multiplication. Now, let's go to the rule about division. Okay, try this. 2 to the 5th divided by 2 to the 3rd. And let's try to write our division as a fraction. So, let me expand that, 2 to the 5th power. Let me expand that, 2 to the 3rd power. All right. Now, something about cancellation. If your mom says, yo, son, let me multiply your daily allowance. Ooh, good. I have $5. You'll multiply it by 2. Yes. But your dad said, no, I'll split it into 2. Split it into 2. Mom multiplied it, but you'll split it into 2. what's the point? Because my $10 will go back to $5. So don't multiply it by 2 because you will also divide it by 2 as if nothing happened. It's just multiplying by 1. So therefore, multiplying by 2 and dividing by 2, the top and the bottom, not as 0, but as 1. Check this out. So, times 2 divided by 2, that's just times 1. Times 2 divided by 2, that's just times 1. So what's the remaining one here? I have 2 to the second power. That doesn't mean that's 0 below. There's a hidden 1. So how do I write that? 2 to the second power divided by 1. There you go. But remember, if the denominator is a 1, you could just leave the numerator as it is. So 2 to the second power. Oh, Ram, that's too much work. Okay, yes, it is. But think of a shortcut now. Okay, what have you observed? Look at the exponents, and what did we do with the base? All right, correct. You copy the same base, but the two little exponents there, what do I do with them? I subtracted them. Awesome. One more. 7 to the 4th divided by 7 to the 3rd. You can do it mentally now. Yes, I know. But let's try to show the work. 7 to the 4th over 7 to the 3rd. Okay. Cancel out. Cancel out. Cancel out. The remaining is a 7. So 7 to the 1st, there's only 1 over 1. And normally you don't write the 7 to the 1st. Just leave it that way. Or simply 7. Okay. So again, what did we do? Copy the same base. And then the exponent, you simply subtract them now. That works for division. Okay, so let's generalize that rule. So we said b to the m divided by b to the n is equal to what? We said b to the m minus the n. Okay, remember, for the base, we copy them. And for the exponents, we subtract them. Okay, so this is the second rule of exponents. It only works for division. Remember, that's division. Try this on your own. Now you're ready? Okay, here we go. Divide means I subtract. There you go. 16 minus 5 is 11. Copy the base 6. Okay, we're good with that. How about this? 9 to the 6. Awesome. We subtracted the exponents. Some kids are tempted to divide 12 by 6. No, subtract. 10 to the 5th power. Correct. You got it right. Number 4 is quite challenging. Why? Because check this out. The bases look different. This is a 36. Did you see that? You might think that was a 35. Therefore, I have to do this one first. That's subtracting. That's 35 to the 1st. But I can do anything about 36 base because they have different base. Okay? So leave it as it is. The next one. Divide and divide. Do it left to right. So let's do this first. 13 minus 6 is a 7. There you go. That's a 7. But there's another division here. So subtract that 2. So 7 minus 2 is a 5. There you go. 15 to the 5th power. Their all bases are the same. But the top is multiplied first. So 79 to the what power? That's an 18. And then 18. But remember, there's a division below. So minus 5. 18 minus 5 is 13 power. Try this on your own. Ready? Time's up. Here are the answers. 12 to the 17. 23 to the 16. Don't be scared of the 1/2. 1/2 to the 33rd. A negative and a positive. Remember how to add a negative and a positive? 4 to the negative 2nd power. Yes, you could put a negative exponent. 15 to the 33rd power. 3/4 to the 1st power. Try this on your own. Okay, ready? These are the answers. So on top, I add them, but at the bottom, I divide them. Therefore, I subtract the exponents. Correct. Next, add them up. I get 6 to the 10 divided by 6 to the 18. Subtract them, but this is 10 minus 18, not 18 minus 10. So your result will be a negative. Yes, an exponent of a negative is possible. Next, same base, subtract 89 to the 88. Next, I subtract 12 minus 1, remember there's a hidden 1 here. That becomes 15 to the 11th power. This one is 0 plus 1. Remember you add it. That's become 12 to the first power. Then I divide by 12 to the third power. 1 minus 3, not 3 minus 1. And you get a negative 2. Okay, you got it? So that's the rule for multiplication and division. In the next videos, we'll be dealing with other rules, other complicated and challenging rules. So don't forget to subscribe and watch the other related videos. See ya.